Millions of people cross bridges every single day in Texas, and most of them have no idea what's underneath them. Not the river, not the drop, the reports. The federal inspection reports that use words like structurally deficient and scour critical, and then, and this is the part that should keep you up at night, leave the bridge open anyway. There's a bridge in Houston that carries over 200,000 vehicles every single day. Federal engineers flagged its deck. Traffic never slowed, not once. Texas has more than 54,000 bridges. Hundreds of them fail federal safety thresholds right now, today, while you're watching this. And here's the thing. Structurally deficient doesn't mean closed. It means watch and wait. It means we know and we're monitoring it. And in the meantime, go ahead and drive across. The 10 bridges on this list aren't just terrifying to look at. There's a specific documented reason experienced drivers white-knuckle them. Truckers who've crossed the whole country refuse some of these. And it's not the height. It's not the length. It's what they know that you don't. Starting at number 10. You're on a long, flat coastal crossing somewhere in South Texas. No trees, no buildings, nothing to break the wind for miles in either direction. The bridge goes on longer than you can see, dead straight, open sky above you, water below. And then it happens. A gust hits your car from the side and your vehicle moves. Not because something's wrong with your car. Not because you drifted. The bridge moved. You can feel it flex under you like a slow, rhythmic pulse. Here's what most drivers don't know. That movement is intentional. Long, flat bridges are built to sway. Engineers call it tolerance. Drivers call it terrifying. But here's what they don't tell you. When a crosswind hits at highway speed, your car moves with the bridge, not against it. And if you overcorrect, you're the one causing the accident. Reports of drivers pulling over in the middle of the span, frozen, too scared to keep going. Which creates its own problem, because there's no shoulder, and the car behind you can't stop in time, and suddenly a bridge that was working exactly as designed has a pileup on it. TXDOT says the sway is within tolerance. There's no warning sign for crosswind behavior. Hundreds of Texas coastal bridges share this exact design. You've probably crossed one. Number 9 looks fine from the outside. That's what makes it worse. It's an older overpass, built sometime in the 60s or 70s, still carrying daily commuter load, concrete surface. Nothing visually alarming unless you know what you're looking for. Look at the edge of the deck. Look at the underside where the lane meets the barrier. You can see it. Concrete chunks missing. Dark, rust-colored staining bleeding down the face. Places where the surface has flaked away, and you can see the metal underneath. That metal was never supposed to see daylight. It was supposed to be sealed inside the concrete forever. But Texas humidity and road treatment over decades worked its way in, and now the steel is rusting, and rust expands, and when it expands, it cracks the concrete from the inside out. The bridge is coming apart from the inside, and the surface looks like nothing worse than some weathering. Debris from Texas overpasses has struck vehicles below. It's documented. The inspection cycle is every 2 years. A lot can change in 24 months. ASCE data suggests 1 in 3 Texas bridges shows signs of this kind of deterioration. You're not looking at one bad bridge. You're looking at a pattern. Number 8 is the one that should scare you most so far, because you will never see it coming. It sits over a Texas river. Trinity, Brazos, Guadalupe, take your pick. It looks solid. It looks like it's been there forever, and will be there forever. But under the waterline, where you can't see, the riverbed around the foundation is gone. Floodwater carved it away, slowly, over years. And now, the base of the support pier is sitting in a hole. Picture pulling sand out from under a table leg. The table looks level. The table looks fine, right up until it doesn't. Federal data identifies scour, that's the erosion of the riverbed under bridge foundations, as the single leading cause of bridge collapse in the United States. The Hatchie River Bridge in Tennessee collapsed this exact way in 1989. 8 people died. Texas has dozens of bridges currently listed as scour critical. Some have sensors, not all. And Texas flooding isn't what it used to be. Storms that once came every 50 years are coming every 10 now. The timeline that was once acceptable is accelerating, and the bridge still has no visible sign anything is wrong. Number 7 is a rural farm-to-market bridge with a weight limit sign posted at both ends. You've seen these. Small bridge, 1 lane sometimes, the sign says something like posted, 20 tons. And then a fully loaded oilfield truck goes across it anyway. 40 tons, 50 tons. Because the driver is behind schedule, and the detour is 40 minutes, and nobody's watching. That sign was posted based on a design from the 50s or 60s when the heaviest thing crossing it was a tractor. Every overweight crossing is a bend of the paperclip. You can't see the damage building. The bridge doesn't make a sound. Texas has more than 800 rural bridges rated structurally deficient, and a significant number of them sit directly on oilfield haul routes with no alternative path. The weight limit sign isn't a suggestion. It's a countdown. And enforcement requires a law enforcement presence that rural Texas counties simply don't have the budget for. The people making the decision to cross are making a calculation. The bridge doesn't get a vote. Numbers 6 and 5 are where history stops being history. In 2007, a bridge in Minneapolis collapsed during evening rush hour. 13 people killed, 145 injured. The cause was a design error in a steel connection plate, a standard from the 1960s. Texas built hundreds of bridges to that same era's standards. Some of them are still open. Number 6 has known steel fatigue in its connection hardware. Inspected, documented, monitored, open. Here's what nobody tells you about steel fatigue cracks. They don't grow at a steady pace. They can sit stable for decades and then accelerate rapidly under the right load. Like a crack across a phone screen. Stays in the corner for months, then one drop, and it's edge to edge in a second. Number 5 is on the Gulf Coast, built before the storm modeling changed after Katrina. It sits in a storm surge zone that's been completely recalibrated since it was designed. The bridge wasn't built wrong. The ocean changed the rules. In Louisiana in 2005, storm surge took out bridge spans that were evacuation routes. The people who needed to get out couldn't. Texas has bridges in the same position right now. Replacement funding is in the queue, years out. Numbers 4 and 3 already partially failed. Number 4 had a documented emergency closure. A section of deck, a support, something that gave way enough that engineers shut it down. Here's the part that should stay with you. It didn't fully collapse, not because the engineering held, but because a backup system absorbed the load when the primary failed. That backup is now carrying weight it was never designed to carry. Cars crossed it hours before the closure. Some may have crossed it during the early stages of failure and never knew. Number 3 is a thermal story, a bridge somewhere in industrial Texas where the expansion joints corroded, and on a summer day when the steel tried to grow the way steel does in 110-degree heat, it had nowhere to go. It buckled sideways. Texas summers don't just melt the asphalt, they push bridges laterally. Expansion joint inspection is part of the biennial review cycle. Joints corrode between cycles, and Texas heat extremes aren't stabilizing. What used to be a manageable annual stress is now a recurring structural event. Number 2 is still open. That's the most important thing to understand about it. Multiple engineers have flagged it. Internal records, accessible through public records requests, show that the compounding condition, deck deterioration plus foundation erosion plus aging steel, was raised as a combined concern. Federal guidelines have thresholds for each individual deficiency. There is no threshold for all 3 at once. Tens of thousands of vehicles cross it every day. School buses, emergency vehicles, commercial trucks. The engineers who inspect it won't tell you it's safe. They'll tell you it's within tolerance. And those are not the same sentence. Within tolerance is the language you use when the cost of closing a bridge is politically impossible. It's the language of budget management wearing the clothing of safety management. The engineers know the difference, and now so do you, which brings you to number 1. And number 1 isn't a single bridge, it's the category. Texas has more than 680 bridges currently rated structurally deficient, according to the most recent federal data. Estimated replacement cost runs into the billions. The Infrastructure Act sent money. The queue runs 10 to 15 years. Every year in that queue is more flood cycles, more heat cycles, more overweight trucks, more fatigue. Here's the thing that experienced drivers understand that most people don't. When a trucker slows down on a bridge, or a local tells you to take the long way, or you feel that particular vibration under your wheels that doesn't feel right, that's not irrational fear. That's pattern recognition. Bridges communicate through movement and sound, and the way your steering wheel trembles at certain speeds. Drivers feel the early signals years before the reports catch up. The scariest thing about these bridges isn't that they might fail, it's that the system built to fix them was designed for a Texas that no longer exists, and nobody has rebuilt the system yet.